Hello friends, I am Balaji Rao from the Masters PU College. In last class, we did 6 problems in exercise number 4.5. In this class, we are going to do few more problems in exercise number 4.5. In next class, I will complete this exercise. You observe this question, they are asking find the inverse of this matrix. In last class, 5th problem, 6th problem is also finding inverse of a matrix, but that matrix is 2 by 2 matrix. Here they are asking to find the inverse of this matrix. This is 3 by 3 matrix. In earlier classes, we learned the formula to find inverse of a matrix. What is the formula to find inverse of a matrix? A inverse equal to 1 by det A into adjoint A. That is the formula. A inverse is 1 by det A into adjoint A. Okay, so you need two things. See here, this is the formula, A inverse formula, 1 by det A into adjoint A. So to calculate inverse of a matrix, you need two things. One is det A, another one is adjoint A. So I'm going to calculate both det A and adjoint A. Okay, first you take given matrix as A. Now calculate its determinant. Calculate the determinant by using first row, okay, det A. 1 into, delete the corresponding row and corresponding column, right? Delete this row and this column, determinant of 2405, okay, minus 2 into, delete this corresponding row and corresponding column. I am calculating determinant by using first row. By this time you are very familiar how to calculate determinant of a matrix. Minus 2 into, delete this row and this column, 0405, determinant of that, plus 3 into, delete this row and this column, determinant of 0200, right? Expand this further, 1 into expansion of determinant of 2 by 2 matrix. What you will get? 2 into 5, 10 minus 0, minus 2 into 0 minus 0, plus 3 into 0 minus 0. If I simplify this further, what I will get? 10 minus 0 plus 0, which is same as 10. So I calculated det A, I got answer 10. You remember here, if determinant of A is 0, then A inverse does not exist, because what is the formula of A inverse? 1 by det A into adjoint A. Here if det A is 0, then this inverse is not defined. So here what you got? Det A you got. What is det A? Det A is 10. It is non-zero number, right? Now I am going to calculate adjoint of this matrix. I want to calculate adjoint of this matrix. What is adjoint of a matrix? Adjoint of a matrix is transpose of cofactor matrix. Transpose of cofactor matrix. Now, I am going to calculate cofactors of all the elements. Cofactor of this element is denoted by capital A11. Cofactor of this element is denoted by capital A12. Cofactor of this element is denoted by capital A13. Cofactor of this element is denoted by capital A21. Like that, I am going to calculate cofactors of all these elements. I written here, see, A21, A22, A23, A31, A32, A33. All these are cofactors notation. I hope you are understanding, right? So now I'll calculate cofactors of all these elements and then I'll calculate adjoint A. What is adjoint A? Transpose of cofactor matrix. See, I'll calculate cofactors and I'll transpose to calculate to get adjoint A. Okay. Now here, after writing this cofactor signs, you just simply go with plus minus alternate symbols. We already discussed in last class also why we are getting this. See, 1 plus 1 even number. When even number is there, plus will come. As per the definition of cofactor, in cofactor definition and examples I explain this clearly. Here 1 plus 2 is 3. 3 is odd number. When odd number is there, minus sign will come. 1 plus 3 is 4. 4 is even number. When even number is, plus will come. If you don't want all this, just simply go with the plus minus plus alternate symbols you start writing, right? Now, minor of this element. Minor of this element is obtained by deleting first row and first column. You see here, in this delete the first row and first column, what you will get? Determinant of 2405. That only it is there, right? Now, minor of this element. Minor of this element, how you will get? It is the determinant obtained by deleting first row, second column. Delete the first row, second column. First row, second column, you delete determinant of 0405. See here, 0405. Now, A13. capital A13 you written plus here. Now you need minor of this element. Minor of this element is obtained. It is the determinant obtained by deleting first row and third column. Delete the first row and third column. Delete the first row and third column determinant of 0 to 0, 0. Look here, 0 to 0, 0. Like that you write all these minors. So in earlier classes also we learned how to calculate cofactor of an element. You just write like this. Now you expand this determinant as plus is there, here plus is there. 2 into 5, 10. 10 minus 0. So finally you will get 10 for this. You write this minus as it is. Now you expand this determinant. 0 into 5, 0 minus 0 into 4 is 0. When you simplify this, you will get 0. Here this one plus 0 minus 0, that is 0. Here minus is there, and that's why I written minus here. 2 5s are 10 minus 0, that is minus 10. I hope you are understanding. Like that you calculate cofactors of each elements. These things we already discussed in last class also. Last two classes. Last class we calculated A inverse, and before that class also we calculated A inverse of 3 by 3 matrix. You just calculate cofactor of all the elements, then you will get the elements like this. Now you write 10 0 0. Look here, 10 0 0. Now next minus 10 5 0, minus 10 5 0. Next 2 minus 4 2. These are the cofactors of the matrix A. What is adjoint A definition? Adjoint A definition is transpose of cofactor matrix. You transpose this matrix, whatever you will get, that is adjoint A. You know how to transpose the matrix. You write first row as first column. You write second row as second column. Third row as third column. Right? See here, first row written as first column. Second row written as second column. Third row written as third column. What happened here? I got adjoint A. What they are asking in the question? They are asking A inverse. To calculate A inverse, what is the formula? 1 by det A into adjoint A. Det A already calculated in the beginning. We got det A as 10. Adjoint A, just now we got adjoint A. So A inverse formula 1 by det A. Det A is 10 into adjoint A. If you want, you can multiply each element of this matrix with 1 by 10, or else simply you can leave this here. Right? I hope you understand how to calculate inverse of a 3 by 3 matrix. How to calculate inverse of a 3 by 3 matrix? Simple thing, you need to calculate A inverse, you need to know what is A inverse formula. What is A inverse formula? A inverse formula is 1 by det A into adjoint A. To calculate A inverse, you need to know two things. One is det A, another one is adjoint A. What is the definition of adjoint A? Adjoint A is transpose of cofactor matrix. So simple thing, you calculate cofactors of all the given elements and then transpose that matrix. Transpose of cofactor matrix is the adjoint A. Once you got det A, adjoint A, you just simply substitute in the formula so that you will get A inverse. Right? Now we'll move to next question. See, find the inverse of the following. All these are 3 by 3 matrices. Seventh question is also 3 by 3 matrix only. I want you to try these problems as a homework problems. Inverse of this matrix. How to calculate inverse of this matrix? First you take this matrix as A. Then to calculate A inverse, what is the formula? 1 by det A into adjoint A. So you need to calculate two things. First calculate det A. From the beginning of this chapter we are doing determinant. You know how to calculate determinant of this matrix, right? After calculating det A, you calculate adjoint A. How to calculate adjoint A? You calculate cofactors of each elements. After calculating cofactors of each element, you transpose that. Transpose of cofactor matrix is the adjoint A. Once you got det A, adjoint A, just simply substitute in the formula A inverse equal to 1 by det A into adjoint A. I want you to try these problems your own. Practice makes man perfect. Don't be lazy. Whatever the problems we are doing in this chapter called determinants, all are continuation. If you are not good in last class, you cannot understand this, because if you don't know what is cofactor minor, how you will calculate cofactors of all these elements while finding inverse? So this is not a solo class. Only by listening this class you will understand everything. It is important to have previous classes knowledge. So in case if you not gone through the last videos, previous videos, please go through those things. Then only you can understand all these things, right? I want you to try all these problems and be careful. These problems are very easy, but only the thing is so much of simplification is there. In the process of doing simple simplification, if you do a simple mistake, small mistake, in the middle. At the end you don't get the answer. Later to search where you did the mistake, it takes so much of time. So do it slowly, make sure each step is correct or not, and finally you will get the answer. The procedure is very easy, but where the problem will come, so many simple simplification steps are there. In the process of doing hurriedly, if you do in place of minus, if you write plus, you don't get the answer. Later to get the answer, it takes so much of time to identify where is the mistake. Instead of that, do it slowly in the beginning until you will get perfection. Later you can do faster, right? Now we'll move to next question. Find the inverse of this matrix. This is the 11th question. This is similar to last question. To calculate inverse of a matrix, we need two things. What are those two things? One det A, adjoint A, because A inverse formula is 1 by det A into adjoint A. So first I will calculate det A and then I will calculate adjoint A. Okay. Det A, you know how to calculate det A. Here I am calculating det A by using first row. See this 1 into, delete this row and this column, determinant of cos alpha sin alpha minus cos alpha, minus 0 into, see here this 0 into, delete this row and this column, determinant of 0 sin alpha 0 minus cos alpha, plus 0 into, delete this row and this column, determinant of 0 cos alpha 0 sin alpha, right? 1 into, multiply these two, minus cos alpha into cos alpha cos square alpha, minus sin alpha into sin alpha sin square alpha, right? Minus 0 into whatever value you will get here, that is 0 only, plus 0 into whatever you will get, that is 0 only. So here you can take minus common, take minus common, what you will get here, cos square alpha plus sin square alpha. Cos square alpha plus sin square alpha is 1. I hope you are understanding, right? So this is the matrix A, given matrix. I calculated det A, I got determinant of A is minus 1. You remember that when det A is 0, then A inverse does not exist because of the formula. Here when det A is not equal to 0, that's why A inverse exists. If det A equal to 0, then A inverse does not exist. Okay, first I calculated det A. Now I need to calculate cofactors of each element. Cofactors of all these elements are denoted by, see, cofactor of this element, this is the element present in first row, first column, it is denoted by capital A 1 1. Cofactor of this element is denoted by capital A 1 2. Cofactor of this element is denoted by capital A 1 3. Like that, you write the cofactors of all the elements. First you write these things, A1 1, A1 2, A1 3, A2 1, A2 2, A2 3, A3 1, A3 2, A3 3. Write all these things first. Now you just write alternate symbols. I already explained why to write alternate symbols. 1 plus 1, even number means plus. 1 plus 2, odd number means minus. 1 plus 3, odd, even number means plus. 2 plus 1, odd number means minus. Or else simply just write plus minus, plus minus, plus minus, plus minus, plus. Alternate symbols start with plus. Okay, now you expand this determinant, what you will get, minus cos square alpha minus sin square alpha. Take minus common. If you take minus common, what you will get, cos square alpha plus sin square alpha. Minus of cos square alpha plus sin square alpha value is 1. Minus sign we already written. You need to write minor of this element. What is minor of this element? It is the determinant obtained by deleting first row second column. First row second column, determinant of 0 sin alpha 0 minus cos alpha, right? Minus 0 into minus cos alpha is 0, minus 0 into sin alpha is 0. Now A13 plus sign you will write. Now this is the minor of element present in first row third column. How you will get this? This is the determinant obtained by deleting first row third column. Delete the first row third column. Determinant of 0 cos alpha 0 sin alpha. When you simplify this, 0 into sin alpha 0 minus 0 into cos alpha is 0. Finally you will get 0. Similarly, suppose you want to calculate a cofactor of third row second column element. You know this is odd number, that's why minus. How you will get this? This is the minor of an element present in third row second column. What is the minor of this element? It is the determinant obtained by deleting third row second column. Delete the third row and second column. Delete the third row and second column. What you will get? Determinant of 1 0 0 sin alpha. See here, 1 0 0 sin alpha. Simplify this. Minus 1 into sin alpha minus 0, that is minus sin alpha. This is minus sin alpha. Like that, you calculate cofactors of all these elements. Cofactors of all these elements. From last 4 classes, I'm talking about cofactors. By this time you must be good in what is cofactor, how to calculate cofactor of an element, right? Once you go to these cofactors, you write all those. See, minus 1, 0, 0. Look here, minus 1, 0, 0. 0 minus cos alpha minus cos alpha. Look here, 0 minus cos alpha minus cos alpha. 0 minus sin alpha cos alpha. Right? Now you transpose this, because what is adjoint A? Adjoint A definition is transpose of cofactor matrix. You transpose this. You write first row as first column, you write second row as second column, you write third row as third column, so that you will get transpose. You know how to write the transpose of a matrix. Okay, what happened? You got two things. One is det A. What is det A? Det A is minus 1. See here, you got det A is minus 1. Now see here, you got adjoint A, right? What is A inverse formula? A inverse formula is 1 by det A into adjoint A. Det A is minus 1. And I written adjoint A, what I got here. Now 1 by minus 1 is minus 1. So each element of this matrix you multiply with minus. You can stop this here, as simplification is easy here. I am simplifying this further. Here minus 1 is there. Multiply, this will become plus 1. Minus 1 into 0, that is 0. Minus 1 into 0 is 0. Minus 1 into 0 is 0. Minus 1 into minus cos alpha, that is cos alpha. Minus 1 into minus sin alpha is sin alpha. Minus 1 into 0 is 0. Minus 1 into minus cos alpha is cos alpha. Minus 1 into cos alpha is minus cos alpha. What is this? This is A inverse. So from last 5 problems are finding inverse of 3 by 3 matrix. We completed these 5 problems in this class. I am going to do one more problem. It is little lengthy problem. We will see what is that. I hope you understand how to calculate inverse of a matrix. Calculating inverse of a matrix is very, very important, because next exercise we will solve linear equations by matrix method. In all the problems we will calculate A inverse. From last exercise, that means 4.6 exercise, one 5 mark question, 100% guarantee. In that exercise we will calculate inverse of 3 by 3 matrix. To solve those equations we will calculate A inverse. So you must be good in calculating inverse of a matrix, right? Simple. How we will calculate A inverse? Two things you need. One is det A, another one is adjoint A. You take given matrix as A and you calculate det A and adjoint A. What is the formula of A inverse? 1 by det A into adjoint A. Substitute in that formula so that you will get A inverse. It is must. You must be good in how to calculate inverse of a matrix. Now we will move to next question. This is the 12th question. They are given like this: two matrices, matrix A, matrix B. They are asking verify that AB whole inverse equal to B inverse A inverse. Actually this is easy problem but little lengthy problem, right? So I'll calculate this LHS first. What is LHS? AB whole inverse. I want to calculate inverse of a matrix AB. For that first I need AB. So I'll calculate AB. AB means product of these two matrices. You know how to multiply two matrices. In matrices chapter you learned first row, first column. See, 3 6 are 18 plus 7 7s are 49. First row, first column is over. Now first row, second column. 3 8s are 24 plus 7 9s are 63. Okay. Now second row, first column. 2 6 are 12 plus 5 7s are 35. Second row, first column over. Now second row, second column. 2 8s are 16 plus 5 9s are 45. I hope you are understanding, right? 18 plus 49, 67. 24 plus 63, 87. 12 plus 35, 47. 16 plus 45 is 61. So after calculating AB, I got the matrix AB like this. Now what I need? AB inverse. AB inverse. What is the formula for AB whole inverse? 1 by determinant of AB into adjoint of AB. See here. AB whole inverse formula is what? 1 by determinant of AB into adjoint of AB. So what I need here? I need two things. One is determinant of AB, another one is adjoint of AB. So I will calculate determinant of AB. Determinant of AB. This is 2 by 2 matrix. Now calculating determinant of 2 by 2 matrix is very easy only. 67 into 61 minus 47 into 87. 67 into 61 is 4087 minus 47 into 87 is 4089. When I subtract, I am getting minus 2 here. So determinant of AB is minus 2. To calculate AB whole inverse, what I need? I need two things. One is determinant of AB, another one is adjoint of AB. Now I'll calculate adjoint of AB. In earlier classes you learn calculating adjoint of 2 by 2 matrix is very easy. It is not like 3 by 3 matrix. Very simple method is there. What is that? You just interchange these two elements here, 67, 61. Interchange here, 67, 61 is there. You interchange them. You see here 61, 67 and change the sign for these two numbers. We already discussed this in earlier classes. You just change these two numbers and change the sign for these two. So you will get adjoint. You see 61, 67 minus 87 minus 47. You get adjoint of AB, right? Now I am calculating this LHS na AB whole inverse. What is AB whole inverse? AB whole inverse formula is 1 by determinant of AB into adjoint of AB. 1 divided by determinant of AB we got minus 2 na? This we got minus 2 into adjoint of AB just we calculated. I want to simplify this further. Multiply each element of this matrix with minus 1 by 2. Multiply each element of this matrix with minus 1 by 2. Minus 61 by 2. Minus of minus will become plus 87 by 2. Minus of minus will become plus 47 by 2. Minus 67 by 2. So I calculated AB whole inverse. Right? Now I want to calculate this RHS. What I'll do? What is RHS? B inverse into A inverse. So what I'll do? First I'll calculate A inverse, B inverse. Later I'll multiply both. So first I'll calculate A inverse. What is the formula for A inverse? 1 by det A into adjoint A. So I'll calculate det A. See, det A is what? 3 5s are 15 minus 2 7s are 14. So det A is 1. And I'll calculate adjoint of this matrix. As it is 2 by 2 matrix, calculating adjoint A is very easy. You just interchange these two elements. 5 3. Look here, 5 3. Interchange these two elements. Okay, now change the sign for these two elements. Minus 7 minus 2. Look here, we got it. So I'll calculate A inverse now. What is A inverse? 1 by det A into adjoint A. What is det A? Det A we got here 1 into adjoint A. 1 by 1 is 1 only na? So each element you multiply with 1, again you will get the same thing only. I calculated A inverse. Now I need B inverse also. What is B inverse formula? 1 by det B into adjoint B. So to calculate B inverse you need two things. One is det B, another one is adjoint B. So calculate det B, determinant of B. 6 into 9, 6 9s are 54 minus 8 7s are 56, right? 54 minus 56 is minus 2. Now adjoint B. Calculating adjoint of 2 by 2 matrix is very easy. Just interchange these two elements. 9 6. Look here, 9 6. Change the sign for these two elements. Minus 8 minus 7. I hope you are understanding. Determinant of B is there. Adjoint of B is there. So you can calculate B inverse. What is the formula? 1 by det B into adjoint B. So 1 by det B. Det B is minus 2 into adjoint B. Now what I'll do? Each element of this matrix I'll multiply with minus 1 by 2. So what you will get? Minus 9 by 2. Minus of minus plus 8 by 2. 8 by 2 is 4. Minus of minus plus 7 by 2. Minus 6 by 2. That is nothing but minus 3. So what happened? I calculated A inverse, B inverse. Actually what is RHS? RHS is B inverse, A inverse. So I am going to calculate RHS. B inverse, A inverse. I written B inverse first. Next A inverse, that what we calculated here. A inverse. I written B inverse, A inverse. Okay. Now you multiply these two matrices. You know how to multiply. First row, first column. First row, second column. Second row, first column. Okay. Second row, second column. Simplify these things further. You will get like this. You observe this equation 1 AB whole inverse and equation 2 B inverse, A inverse. Both are same. Minus 61 by 2, minus 61 by 2. 87 by 2, 87 by 2. 47 by 2, 47 by 2. Minus 67 by 2, minus 67 by 2. From these two equations, what you can say? You can say that this expression is same as this. So from 1 and 2, we can say that AB whole inverse equal to B inverse into A inverse. I hope you are understanding these problems. See, this determinant chapter, except second exercise, remaining all exercises are very easy. Only the thing is more simplification will be there. You can overcome easily with practice. Practice is the only solution. Take pen, paper and start practicing all these problems. Luckily nowadays you are getting more free time to practice the things. So don't waste this time. by watching movies or by playing games in mobile. Instead of that, you spend more time to practice the things. Luckily you got this time. Please utilize these online classes. I hope these videos are helpful to you. Thanks for watching this video. Have a great day. Bye bye.